I have the factors of the constant term, 1 and 2 and 3 and 6, over the factors of the first number, the leading coefficient, 1 and 3. So I have my possibilities. Make my combinations. 1 over 1 is 1. 1 over 3, 1/3. 2 over 1 is 2. 2 over 3 is 2/3. 3 over 1 is 3. 3 over 3 is 1. Already got it. 6 over 1 is 6. 6 over 3 is 2. I already got it. I don't know why I circled it. I really don't need to do that. I don't want you to think that's the answer. So we have 1, 2, 3, 4, 5, 6, 12 possible numbers here, because that's always the positive and negative of all those combinations. Okay? Now, this polynomial has a power of 4. So that means there's going to be 4 solutions. Okay? So we set it up. 3, negative 11, negative 1, 19, positive 6, 4, 3, 2, 1, 9. And what do you want me to try?
2.
2. Okay.
Yeah, 2 words.
All right, so my first number comes down, and then I multiply, and I add. And I multiply, and I add. And I multiply, and I add, and I multiply, and I add. Now, this has only reduced now remainder, constant, x, x squared, and x to the third. We can't factor an x to the third power. So you're going to do synthetic division again until you get it to an x squared. Now, I'm just going to throw this out. And I don't know if I did it or not. I really can't remember. But 2 could be the answer again. Okay? You could actually have the same 4 answers. Okay? It's possible. I think I made them different, but I can't be 100% sure. It's been a while since I made it out. Okay, so what do you want me to try? Let's try something different. Try 3? I have no idea. Okay, so 3 comes down. We multiply. We add. We multiply. We add. That worked nicely. We multiply. We add. We got our remainder of 0.
Why are we so lucky?
I don't know. We really are getting lucky because that doesn't typically happen.
To me.
So now I get my remainder constant x squared. So I have 3x squared plus 4x plus 1, set that equal to 0, and we factor that. 3x, 1x, I only can choose 1 and 1, so that's going to work. There's only one choice for all of that. So what are the 2 roots from this? The first parentheses, 3x plus 1 gives me what?
Negative 1/3.
Negative 1/3. And then this one gives me negative 1, and then my 2 that I used with synthetic division. So negative 1/3, negative 1, positive 2, positive 3. Okay, without having to go through another one, do you think you're good with that?
Yes.
Okay. I don't think I gave you, no, I'm sure I didn't. If I had, let's just say, a power of 5, then I would have to go through and do synthetic division 3 times. Good. Okay? I don't think I gave anything like that. But you have to get it to have it reduced to a square so that you can either factor it or, when you get to be a junior, plug it into a quadratic formula. Okay? When it doesn't factor. And again, I was nice, and I always made sure that my synthetic division had some integers, but that's not always the case. because you actually can get imaginary numbers with this too, and fraction and all of that, so, okay. All right,